this instrument is an ICP mass spec, standing for inductively coupled plasma mass spectrometer, and its use is to detect mostly contaminants or just inorganic metals in water. So, for example, today we're going to be testing lead in water, arsenic in water, uranium in water, and basically the benefit of this instrument is that is its sensitivity. It can detect down to part per billion and less than part per billion, which is 1 microgram of a contaminant per liter. Is what a part per billion is. That's what I'll be speaking in. So, for example, if you want to get an idea of this, how much arsenic, for example, does the government allow you to have in your drinking water at home? And the answer is 10 parts per billion. So that kind of gives you an idea of how low a part per billion is and the level at which we're detecting. And so therefore the importance of what we're detecting today is water purification. How pure is water? I have a sample here today from one of my friends who just moved into a house with lead pipes, and they want to check, is there actually lead coming off into their water, their drinking water at home? They have a new baby at home and they just bought the house. They really don't want to be exposing themselves to it, so they want me to check this and see if they need to have some kind of water purification process. So we're going to see if it's within for lead, the limit is 5 ppb. So from that, we will detect and see what we get for their result. Taking a minute to ignite.
And how would you define plasma?
A plasma is, by definition, an ionized gas, which essentially have here, and it's a high temperature plasma, so it acts kind of like, basically like a flame, but like a torch. I don't know if it would show up on the camera or not, but there's a plasma running in this one. You can kind of, if you come up close to it, you can kind of see
it inside.
Yeah, if you come up close, you can see the plasma.
Yeah, you can see it.
So in many ways, it is actually like a flame. The flame will do very similar things.
Okay, so JT, what are you doing now?
I had to do a daily performance test of it, something just to make sure the instrument's running properly.
So basically a control, or just
kind of
just running diagnostics?
It's a diagnostic, yeah.
Okay, so what are this black metal rod into this test tube-ish thing?
Oh, this, okay. So the samples are all going to go here. This is where we're going to put our samples. This is, if you follow the tubing, you can see what's filling this solution comes from this tube, which is constantly being filled from this bottle, which is nitric acid. And this 1% nitric acid is the wash solution. This instrument, everything that goes in this instrument is in 1% nitric acid instead of water. So this is a constant wash of the instrument. It'll keep returning here between each sample to clean itself out, because it'll be an automated system. And this black rod here, this sniffer, actually is what pulls the sample into the instrument. This arm will move around. It's a robotic arm that will move it to each sample. The sample will go through this sniffer, through this tube, through